Good morning, Algebra 2 students, or good afternoon, Algebra 2 students. I know you are all pumped and excited about getting to start a new section this week. We are now headed off into the land of all things squared. In fact, we'll be spending the next 3 months, yes, I said 3 months, looking at equations and functions that contain squared variables. There is much to know about these very important functions. However, if we're going to work with variables that are squared, we also have to be able to work with square roots. And so our next 2 days of class are going to be concerned with working with square roots. You'll notice from the assignment sheet you should have received that you actually just have 2 days of material, and then we will be having a quest next Monday over this fun, exciting stuff. I'm sure the beginning part of this you all have seen before. In fact, most of today, I hope, is a good portion of review for you. We're out today to learn how to simplify square roots and then to add, subtract, multiply, and divide them. There are some interesting little rules that go with square roots that I hope I'll jog your memory about, and maybe you'll learn a few new ones you didn't know before. So, let's get started. The first thing I want to ask you is simply, if I said, what's the square root of 9, what would you all say? And even in this empty room I'm talking to at the moment, I'm sure I heard somebody out there say 3. Well, that's true. And if I asked you what that means, I would probably hear most of you say, well, square root of a number means what number times itself, in this case, makes 9. And you would be right. But my question is, 3 times 3 is 9, but isn't negative 3 also a solution? Negative 3 times negative 3 is also 9. So it should be possible that the square root of 9 actually has 2 values. And that actually is true. It does have 2 values. However, mathematicians back in the deep, dark past decided that, okay, when we do square roots, we are always going to give the positive answer, and they said, let's call that the principal root. So when we work with square roots, we always give the positive value as our solution, not the negative. The biggest problem with square roots is that not every number is a perfect square. So if I was to ask you, for example, what the square root of 28 is, there is no nice, perfect whole number that taken times itself will give you the square root of 28. So hopefully you'll remember that you learned back in Algebra 1 that you actually had to break down the square root of 28 into 2 parts. You had to think of a number that's a perfect square that is a number that will multiply to make 28. And if you go through your perfect square numbers, 1 squared is 1, that's not going to be very helpful. 2 squared is 4. This is 4 a factor of 28? And yes, it is. So what we do is we say, okay, square root of 28 is really 4 times 7. There is a perfect square root of 4. What number times itself makes 4? And yes, you're right, it's 2. So we can take the square root of 4 and we take the 2 out of the root, leaving the square root of 7 inside the root. So the square root of 28 is really the same thing as 2 times the square root of 7. Running one more of those by you before we move along and get a little fancier here. If I said break down the square root of 45, once again, there is no number that times itself is exactly 45. So we have to try to break down the square root of 45. You are looking for a number that's a perfect square that is a factor of 45. Well, once again, 2 squared is 4, but there is 4 times a number that makes 49. So if you move up to your next square number, 3 squared is 9. Does 9 go into 45? Answer is, of course, yes. So we have 9 times 5. And since the square root of 9 is really 3, I can take that out of the root, and I leave the square root of 5 inside the root. So I'm left with 3 times the square root of 5. Let's do a slightly bigger number, and I want to show you one of the pitfalls of square roots. Most of you are looking at 72 going, well, hey, common easy factors of 72 that we all typically use are 9 times 8. And you'd be correct. Once again, square root of 9 is 3, so I'm left with 3 times the square root of 8. The problem is, I'm not done. Isn't there a perfect square number that goes into 8? And yes, we can say 8 is really 4 times 2. So it actually turns out that I can break this one down a second time. The question is, what happens? I know the square root of 4 is going to become 2, but when I take that 2 outside the root here, do I add it to the 3 or do I multiply it times the 3? And the answer is yes. Some of you out there saying it, I multiply by 2. You don't add it. So when I take that square root of 4 out, it becomes a 2. 3 times 2 is actually 6. And I will end up with 6 times the square root of 2 then as my most reduced fruit. Now, the faster way to have done that, rather than having to do it twice, is to also notice that, 72 is really 36 times 2. So if you can think of a bigger perfect square number that works, you can actually break it down faster, because the square root of 36 is 6, and I'm left with 6 square root of 2 again. So it's worth your time to try to think of the biggest possible perfect square number you can use to break it down. But if you don't, you can just continue to break it down 2 times to get to your answer. All right, let's do a little addition and subtraction with our roots. If I said to you, what you get if you take 2 times the square root of 3 plus 4 times the square root of 2 plus 8 times the square root of 3 minus 7 times the square root of 2, what do you get out of all that? That's a lot of roots in one problem. Well, adding and subtracting roots is just like we add and subtract variables. If I gave you 2x plus 4y plus 8x minus 7y and said, simplify that, you always go, hey, I can combine the like terms. I can combine the ones that are the same variables. And we add the coefficients in front. We say, hey, 2 times 2 plus 8 is really 10x. 4y minus 7y is really negative 3y, and we have our simplified answer. It's exactly the same thing when you're working with square roots. You add the like roots. You can only combine the ones that have the same square root on them. You add only the coefficients. You do not add the inside of the square roots. So we would take 2 square root of 3 plus 8 square roots of 3, and if I can add those together, I add the coefficients, I would have 10 square roots of 3. I do the same thing with the square roots of 2. If I add 4 square root of 2 minus 7 square root of 2, I am left with minus 3 square root of 2. Now, can I combine it any farther? And the answer is no. Those are 2 different square roots. You can't combine them any farther. That is your answer right there. So you can only combine roots that are like roots. Now, what happens, though, in this particular instance? What if I was to give you the square root of 24 plus the square root of 54? Just those 2 roots. They're not like roots. They're 2 totally different numbers. So I can't add them together right now. But the one thing we often have to do is we need to get them broken down into their simplest form before we try to add or subtract them. So you would actually need to do like we've been doing up here at the beginning. We actually have to break down those roots and then combine them. So if you ask yourself, all right, what do I know about 24? 24 is really 4 times 6. So therefore, I can take the square root of 4 out, and I'm left with 2 times the square root of 6. And if I take the square root of 54, 54 is actually 9 times 6. Well, square root of 9 is really 3, so I would have 3 times the square root of 6 left. Now that I have them simplified, I can see that, hey, those two are the same square roots. I've got like roots there. I can actually combine their coefficients now. So 2 square root of 6 plus 3 square root of 6 will give us 5 square root of 6, and we can actually combine them together. So you always want to break your roots down into their simplest possible form before you try to combine them. Well, hey, that was no big deal. We can add and subtract roots with no problem. So let's move on to multiplication. Okay, with multiplication, things get a little more exciting because we know that when we multiply numbers together, they get bigger. And so sometimes when you're multiplying with roots, you can end up with a bigger root than you might like. But I'm going to show you a way to avoid some of these issues. But let's start with a simple one first. If I said take the square root of 2 times the square root of 6, the first big question is, can you? Those aren't like roots. Are we allowed to combine two different square roots together? And the answer is yes, we are. So we're going to say, hey, square root of 2 times square root of 6 is really square root of 12. You can multiply it. After you get it multiplied, you have to break it down. Well, what two numbers break down 12? Of course, that's 4 times 3. So the square root of 4 is 2, and I'm left with 2 times the square root of 3. Not anything too terribly difficult. Same thing applies if I take two square roots, but they have coefficients in front of them. When you multiply them together, you multiply the coefficients in front together, and you multiply the insides of the roots together. So we take 3 times 5 and get 15. We take square root of 6 times square root of 3 and get square root of 18. Once again, you'd ask yourself, can I break down square root of 18? And the answer is yes, you can. So 18 is really 9 times 2. When I take that square root of 9 out, that's going to give me a 3. So I'm actually going to have 15 times 3, or square root of, or 45 times the square root of 2. At this moment, I'm going to break this recording because I can't go over 15 minutes and be able to post it on YouTube. So we're going to stop here, and you're going to start part 2 of this recording so that you can catch the rest of this.